It is Tuesday afternoon, 1 p.m. in Switzerland and here in Berlin. Even so, we are broadcasting from Brandenburg, where all of us are in today. It is Space Café Web Talk time, and our Space Café Web Talk 33 minutes with Professor Enrico Stoll will begin soon. Thanks for joining us for our talk today about 30 years of small satellite development at the Technische Universität Berlin. As always, we appreciate your participation and ongoing feedback, and any responses from you are very valuable for us and help us to improve. I'm Torsten Kriening, your host today and publisher of SpaceWatch.Global. We are a Switzerland-based online platform for information in and about space and new space activities in a geopolitical context. I know many of you are already familiar with our website, our bi-weekly and daily newsletters, and the Space Café podcasts. Our latest episode, just released this morning, is another masterpiece by our great host, Markus Moslechner. He talked with Ian Connelly of ESA, the Hera Planetary Defense Mission Head. Check it out. It's worth your time. We also keep our fan shop open online for you to support us actively and become a space watcher. The edition 1 has cool items for you, your friends, and the ones you love. And your support is needed to keep our work alive. If you have missed any of our previous web talks, we have an archive available on our website, in our event section, and on YouTube. So, my guest today, I would describe as one of the hidden gems in our industry. Someone who combines his deep knowledge with his desire to teach and to help to create the foundation of the next generation of top-level researchers and engineers here in Berlin. I had the great pleasure to meet him 4 years ago and work with him on one of the mind-blowing projects I've been involved. So we aimed for nothing smaller than to fire a mobile laser on a moon's surface to melt the regolith while there. So I know it sounds crazy. However, we moved on. So it is my absolute honor to welcome today Professor Dr. Engineer Enrico Stoll to our Space Café. Enrico, welcome.
Hello, everyone. I'm glad to be here. Thanks for the invitation.
Absolutely. So let me say a few words about you to introduce you to our big audience today. Enrico studied mechanical engineering from 1999 to 2004, specializing in aerospace engineering at the TU Dresden, then later on Moscow, and greetings to Australia at the University of North South Wales in Sydney. After completing his study, he moved to the Technische Universität of Munich, where he received his doctorate in 2008. And after his postdoc at the MIT in 2009, he joined RapidEye, and many of you might know them. Today they got acquired by Blackbridge and now Planet for a few years now, decade I think, in 2010. So there he worked as a system engineer with a satellite constellation, completed his bachelor degree in mathematics, and taught at the Free University in Berlin. Since 2014, he has been the head of the Institute of Space Systems in Braunschweig, and this year in February, he moved to Berlin to become the chair of space technology at the Technische Universität of Berlin. With that, welcome back to Berlin and to our Space Café. So let's kick that off. Let's start with a very typical question for someone in Berlin, from one Berliner to the other one. Where have you been when the wall came down in '89? I mean, for you before moving to Dresden.
So probably as some of us, I was born and raised in a land, in a country that doesn't exist anymore. So that was the former GDR, the German Democratic Republic. And I think I was a 4th grader, maybe a 5th grader at the time. So I saw what's going on. Maybe I couldn't understand everything, but what was quite interesting to see everything or all of that. And right before Dresden, I think to connect that loop, I was actually doing my military service. So I was doing my compulsory military service with the German armed forces, and then going to university, and then afterwards could grow my hair actually back.
You know, I had long hair before I went to the military service, but it's a different story then. But coming to today, so congratulations to your new assignment here at the Technical University in Berlin. And without any doubt, there are very big footsteps to fill. I mean, this year also the TU will celebrate the 30th anniversary of small city development here in Berlin. So can you tell us a little bit more about the legacy at the Technical University and what excited you to take this position?
Yeah, so that's definitely a huge legacy. Everything started basically with Professor Renner 30 years ago on, I think it was the 17th of July, 1991. Yes, 1900, that number exists. So 30 years ago, he started his first satellite from the so-called TubeSat family, so TU Berlin satellite. And he was basically starting to use, small satellites, so up to, I think the largest one he started was actually 56 kilograms, something like this. So this was small satellites. Today they're even smaller, of course. But he started optimizing technologies for communication, for attitude determination control, for Earth observation, something like this. So he systematically brought this into small satellites. And he was very, very visionary. He had this satellite lectures and started to involve all the students for educational purposes and so on and so forth. And then I think in 2003, it was as another aerospace chair was founded, and Professor Breeze, so my predecessor, was becoming the head of this chair, or the chair holder actually. And then he started further miniaturizing all the satellites. They both were pioneers in satellite engineering, so all the satellites got smaller and smaller, and still the students had a lot of hands-on education, and a lot of nano-satellite technologies were demonstrated. He did inter-satellite communication with nano-satellites. Then they started to doing orbit determination with CubeSats or with nano-sats, infrared detection. Now we're doing formation flight, spectrum analysis. I think it was the first, probably one of the first, no, it was the first nano-satellite network with inter-satellite communication. And with 27 satellites now in orbit, that might actually be the largest number of launched satellites by an academic chair. And when I say this, I actually have a little smile on my face because, and here say hello to the colleagues of UTIAS in Toronto. I think they have about the same number of launched satellites. I'm not completely sure. So, but we are not bad if it comes to launch satellites. And this is all this technology is part of the big excitement. So all the satellites were basically optimized. There's nano-satellite technology available for all sorts of purposes. And now I would like to use this technology for cooperating with scientists, because I think they're ready, they're mature. We are now in the at a step where we can actually launch very, very interesting payloads, can do swarms, we can do constellations, we could do on-orbit robotics. So this is very, very exciting, and I would like to see this happen in the future.
We will come to that later. So on this, to talk about the school projects you're working on, but let me clarify. I mean, these 27 satellites you launch, they are not just in one constellation, because I know there is also some international work you've done for, I think, Lapan, for Indonesia and other countries in the past. But it's absolutely impressive. So are all these satellites are still in orbit, or did they deorbit that already?
To my knowledge, most of the satellites are still in orbit, and 20 or so are still operational. So most of them are still there, and all of them work. That's the good part of it. So all of them were functional at a time. And these were different missions. So there were missions with only one satellite, there were missions with 2 satellites, and there were missions with 4 satellites. But yes, they are all functional. They are working. Right now, we are doing the LEOP for a satellite we just started like a week ago.
Absolutely, yeah. I was about to mention that last week we saw the SpaceX Transporter 2 mission successfully launched into orbit, and it was amazing work. and not just only that there's a satellite involved. It's also, I think it was over a ton of payloads, and integrated by one of the spin-offs or students or from the TU, or Dimitri and his team at Exolaunch, but also included another, I have to say, really another Berlin satellite, Tube-in, I don't know how you pronounce it. So can you tell us a bit more about this specific one? What is it? What can it do?
So let's try to go with Tubin. That's a little bit the German pronunciation, but it's T-U-B-E-I-N, which is for Technische Universität Berlin, so Technical University of Berlin, TUB, infrared nanosatellite Tubin. So that's what we're saying. He's basically part of the 2X20 bus. So we do have a lot of satellite buses from 20 kilogram, 10 kilogram. We have launched 1 kilogram, 2 kilogram satellites, even 300 gram satellites. So this is the 20 kilogram bus system. The Tubin is, I think, weighing around 17 kilogram, and as the name suggests, is a remote sensing technologies satellite. So remote sensing technologies for nanosatellite. It's carrying 2 uncooled microbolometers or microbolometer images with a resolution of approximately 100 meters. And then it has a third imager aboard with a sensitivity in the visible spectrum about 50 meters of resolution. And yeah,
how big is it? When you said it's a nanosat, so how big is it? So is it 2U, 3U, or bigger?
That's a lot of use. So it's 17 kilograms, and it has that's a special one. So it's it has 8 corners, so it's not the usual quadratic one. But that's a little bit of a heritage. Maybe the old MSATs, something like this. They were octagons as well. So I'd say it's equivalent maybe to something in the 27U range, but you can't really use the U because that would imply that it's a standard, and that's not really standardized.
It's custom built.
Yeah, tailor-made maybe.
Tailor-made, cool.
For all purposes, and we're working in the future. We will try to adhere to the standards, to those standardizations as well. But this one was, as you say, this is a little bit custom or tailor-made. And yeah, as it is a infrared satellite, its purpose is the detection of thermal events on the ground. So we're evaluating the U spectrum of uncooled microbolometers, because we see that infrared detection, so thermal events, maybe wildfire, something like this is pretty huge in the last couple of years. So all this fire detection is a thing now in aerospace industry or in data support for companies. And there are currently a couple of startups also going in this direction. And even in Germany, there are 2 startups going in this direction. And everybody is keen on seeing what kind of data they can produce and whether that's really usable for several applications there.
So greetings to Thomas and Björn of our Aurora Tech in Munich are at that stage. So, but it's interesting. I would like to go back to Braunschweig. The TU in Braunschweig there was also known for their outstanding reputation, brilliant space sector, and great projects. It's also, in my opinion, the hub or one of the hubs for space sustainability in Germany and Europe. And greetings to our friends at Okapi, Jonas, Katrina, and their entire team. So what is the difference because all the universities competing? I mean, let's face it. So what is the difference between Braunschweig and Berlin, and what made you come over? So
yeah, well,
this comfortable share.
In not only the university, but at the time there was really outstanding too. So they have a lot of experience in space debris. The folks there did space debris research like 20, 30 years ago, so long before it was cool and long before everybody knew what was the movie Gravity, that spacecraft can collide and produce fragments. So the colleagues are actually developing the space debris reference model for Europe. so for ESA. So with this, it's called the master model. With this model, they are not only modeling all the trackable objects, which is a little bit easier since you have data, but they are also using statistical simulation to model the space debris up to the submillimeter scale. So from fragmentations, from other stages, can be ashes from solid rocket motors. It can be even coolants from old nuclear reactors aboard Russian satellites and stuff like this. So there is a really, really complex model there, and they are steadily evaluating this one and maintaining this one and improving this one. So there is a lot of expertise available there, and all the PhD students getting a lot of experience with orbit determination, orbit predictions, and so on, with collision avoidance measures and so on and so forth. And sometimes up to that point where they can even start a startup like Okapi Orbits, as you can say, as you said already. So we can say this here with Jonas, Katharina, and then there's Christopher there and Sven as well. So big hello to them as well. There are 3 of the 4 of them are my PhD students. And that was really a great time, and they're doing a lot of research in the framework of space sustainability, but was more like theoretical work there. I tried to do some additional work there, or practical work, where we were developing some, some methods, some technology for space debris removal with CubeSats. So this was the other aspect. But moving then from Braunschweig to Berlin was a kind of tough decision, because the satellite, there was a satellite development here in Berlin, so I could maybe use our technologies, our subsystems, which we developed there in Braunschweig, and maybe let them fly here in Berlin. So we're going to see this one. And Braunschweig is extremely good in aeronautic engineering, but the aerospace engineering, apart from space debris, of course, more or less just started, as I said. So we didn't have a satellite project there. We just acquired one, which I brought to Berlin. And on top of this, the company culture in Berlin is a little bit richer. So there is a lot of startups, a lot of aerospace companies. Yeah, I think that sums it up, and it's a little bit of home here in Berlin for me as well.
Yeah, I mean, let's do some shameless promotion for Berlin. I mean, as I mentioned in my trailer, I'm a proud Berliner as well. So, and I love that people are coming here also to do space in town. I mean, and that's great. You talked about the praxis aspect, the practical aspect in the context of sustainability. So, what does it mean for your work? I mean, there are a lot of discussions on LTS and the long-term sustainability guidelines and so on. What are the projects, the research, or you're involved in now?
Yeah, so sustainability, that's a very interesting and very important topic for us. I think everything goes for us under the umbrella of sustainability in Braunschweig and now in Berlin as well, because we are doing research in miniaturization and satellite miniaturization, would like to bring more and more satellites into space. So this is somehow a double-edged sword, right? We would like to do our research. We have to bring something to space, but on the other hand, that might become space debris in a couple of years. So, however, the sustainability is not only a keyword for us, so we try to really live it. And we are obeying, of course, all the rules for sustainability, for space debris. And on top of this, we are having retroreflectors aboard of all those satellites, since they are growing smaller and smaller, and gets more complicated to really track them by the usual measures. So we're having this retroreflectors on board. We're doing research on space debris removal with CubeSats, since we see that we have to do something in there. We have to remove some kind of high risk objects, high criticality objects. So we have to do this with CubeSats. At least we think we have to make this more cost efficient, all the on-orbit robotics. Otherwise, it won't work in the future. We can't just send one big satellite to remove one other big satellite or one other large upper stage. We are working on so-called Gecko adhesives or dry adhesives to build bio-inspired docking mechanisms which can dock to uncooperative targets. There's a lot of research out there, and we decided to use Gecko materials, so-called. We are doing robotic arms and so on. And last but not least, there one aspect of sustainability in space, which is not very often considered, is the use of the frequency spectrum. So we have a satellite out there who is monitoring the frequency spectrum. So what kind of frequencies are used? When can I use the spectrum? When can't I use the spectrum? Which might be a step into the future when we are saying satellites don't have a fixed spectrum anymore, but they are using the free frequencies which are currently there.
That's interesting. I mean, I had the pleasure to talk to Alexandre Vallée from the ITU, I think a few months back. And I mean, it is raising up to into an issue that we see this scarcity of frequencies, and it's an interesting one. Let's dig further into your future work. I mean, we promoted it also in our invitation. So we talked, or we mentioned sensor network, climate research, in-space manufacturing, 3D printing, and so on. Tell us more about that, and tell me, what is Gecko technology to... I don't get it.
Okay, so well, let's basically first start with our little friend here, the animal, the gecko. We see that all or most of the space debris there is uncooperative. So it's not operated anymore. It's basically dead. And if it's dead, it starts tumbling there because of the perturbative forces or moments up there. So basically what you're having there is a big truck in front of you and starts rotating. So the big question is, how do you catch it? And there is a lot of research there, as I try to emphasize, from different universities and industries. And some people are concentrating on nets, some are concentrating on harpoons, and they already tested this one in orbit. But the problem is, how I see it, you have like 1 or 2 tries. Depends on how many nets or harpoons you use, and then if you didn't catch it, well, the mission's gone. Same or very similar robotic arms. You can try to like grab the object. However, you can't grab everything. You have to grab maybe a launch adapter or some rigid part of the body. And if you don't do this, then there is a problem. And we thought, well, maybe we can mimic nature somehow. And we came up with using this with Gecko material, with the synthetic dry adhesives, together with a lot of partners, and thought that might be a good idea to really have a biologically inspired docking adapter. And with this one, as we were saying, we're basically mimicking the nature and the gecko foot, and it consists of very small hair and lamella system, and it can dock to almost anything, for example, solar cells. And wouldn't that be great if we could dock to any satellite to the solar cells, start to detumbling, and then maybe you remove it, or maybe another big satellite would be coming there and then remove it. So I think that's a good approach, and hopefully we will be capable to show this one. We've tested it already on space station at the end of the year, so in 6 degrees of freedom, so it worked very well. Let's see whether we can bring it to space. Yeah, and as you said, all the nice technologies. You basically already mentioned our roadmap. So we have, what I would like to emphasize is, we have a cool connected sensor platform available. We have miniaturized stuff. We have optimized satellites there. So we are now ready for the big applications. Of big, I mean, to really help the scientists out there to go into atmospheric research, maybe go into Earth observation. We are ready to do locally and temporal distributed sensors. So whoever has an idea, just approach us, and maybe then we can do a cool sensor network. We have already infrared detection there. We're doing Earth observation with visual sensors. We have a project sketch, let's face it this way, or project idea for an ionospheric radiotomography, something like this we have available. But maybe there's of course more people who have more interest in other things, and we would be happy to help understanding the climate, atmospheric processes there. And ultimately it would be really great not only to bring such stuff in orbit, but this is like now 50 years in the future, but to like maybe be capable of manufacturing those sensors in orbit, or only as a medium step to exchange sensors in orbit once they are obsolete, once the satellite would have to be retired because the sensor doesn't work anymore. So why don't we exchange the sensors in orbit, and then at the end of the day even maybe print our own sensor systems with the robotic devices? And yeah, that's the part where additive manufacturing, where on-orbit robotics comes into play. And we already have some experience. As you said, we wanted to do laser sintering of regolith. We did this already under lunar gravity, which doesn't mean on the moon, but in a drop tower in Hanover. So we already have some first experiences with additive manufacturing there.
Pretty cool, pretty cool. Before we come to Mark's question, so one project I would like to talk about is in the context of the robotic arm for CubeSats, what I think is super important. I mean, 3 weeks ago, we talked in our Space Café Canada with Tim Kopra of MDA about Canadarm3, this big monster, this new one for the ISS or for Gateway. Let's talk about now the other end of the scale, the arm for CubeSats. So why is it important? What is the purpose? I mean, is it needed that the CubeSat can scratch its back on its own? Or so, I mean, help me, give me a showcase for that.
Scratching the back, maybe cocktail shaking in orbit. No, no. Honestly, the Canadarm is huge, an excellent project. I'm a big fan of this. But it was built for space station, mostly funded by the government, and it is of course a very cost-intense project, I guess. But on-orbit robotics has to be affordable. At least I think so. Most of you probably know DIOS, the German orbital servicing mission, which was announced back in the end of the 1990s, maybe in the early 2000s, and then there was a lot of development there, and a lot of paper was produced, and then all over a sudden it was dead. And this one didn't work, and I think we have to employ small satellites for the debris removal, because the conventional concepts and don't work anymore with the standard links and the joints of a robotic manipulator. So we develop more or less new kinematics for a CubeSat, for a CubeSat cube. And it's very similar, if you remember the Rubik's Cube. Maybe you know the Rubik's snake, and we developed basically a robotic manipulator that works very, very similar. And you can fold this one into one new satellite, so 10 by 10 by 10 centimeters approximately, and it can extend to 1 meter approximately. So we still have in the process of developing this one. We have a prototype on ground, and we would like to bring it to space. But this one is multi-redundant, so it has a lot of those links. It could theoretically work inside satellites. So with standard arms, all of them are going like this. It's hard to really go into a cube and manipulate there something. So it has hopefully a lot of very, very cool applications, like the scratching or the cocktail mixing there in orbit. We don't know. Even the 3D printing, of course, for 3D printing, you need an arm as well, which maybe like something like this here. And we think it has to be smaller, more affordable, and that's why we are trying to really get this one into orbit and see what's happening there.
Interesting, and it sounds also that it can be modular, that you can connect multiple of these arms together to have the super arm then at the end, or the super snake. So sounds pretty cool. And I mean, I'm looking forward to learn more about it and maybe see it also on SpaceWatch.Global at one day. So, or maybe you guys can let your students or PhD students write an op-ed about it. Would be wonderful and cool and innovative development. So coming to Mark's question, thanks Mark for sending it over. What has been the most interesting development, I assume, in space you saw?
Oh, there are so many developments. I think reusable rockets I'm still fascinating. Every time I'm seeing a rocket landing, I'm like, wow, this one exists. And then I'm going back to the books and see, oh yeah, that actually has to work. And I should be able to explain this, but it is very fascinating to me if this works. And the 3D printing technology is another one which has so many applications, and we can't even see right now where it's leading, right? So we know that we can maybe produce something on the ground, maybe we can print something on the ground, but maybe in a couple of years or decades we can actually build something in space. That's another fascinating one as well.
Yeah, I think there are a couple of 3D printers on the ISS, as far as I know. I think Made in Space or
Right.
NanoRex or do some stuff there. So yeah, interesting to see how that moves on. Um, Also to our audience, if you have a question, please send it in. We are here for you. But again, on this tone of promoting Berlin and promoting our the TU, we have a number of very talented young people that are listening to us usually. So I mean, if I have the question and to decide where to go, why should I study in Berlin? So, and why TU? Why your department? I mean, we should say, yeah, come on, you in. We have a long waiting line. I say, okay, yeah, then I have to be the best, sure. But what attracts people, or how can you attract people to your department?
Well, I think Berlin is very multicultural and open-minded already, so I think I could end this one already here. It's per se very multicultural. I like this one, but TU Berlin is one of the larger universities, of the larger German universities. It has a long heritage. It's part of the excellence strategy of Germany. So yeah, that's for TU Berlin. I guess there's a lot of more points which I could state, but we try to follow this very multidisciplinary approach and work like this at the chair of space technology. In a couple of short words, we try to do cool stuff. So from satellite networks, space robotics, we try to teach hand-on technologies, right? All of the students are involved in some projects in the satellites, maybe then later on in the satellite operations. We are doing the lunar exploration, what you just mentioned, with 3D printing on the moon, recycling of stuff on the moon. I see Frank Koch here in the audience. We work together with him to try to recycle some material on the moon. We're doing rocket technology. We're doing 3D printing. So I think everybody who's fond of technology and maybe space is very welcome to come here and do research with us and try to get some hands-on on very cool stuff.
Just to clarify, you guys are teaching in English or mix of English and German?
It always depends. So we have we have an international study. So we have where it's only done in English. Usually the lectures are in German. However, I have all my slides in English, and if there is the need, I usually switch then at the start of the semester into English if somebody says I would like to hear this one in English.
Okay. Cool. So another question from Eric Krohn. What priorities do projects concerning satellite communication with focus on communication capabilities from the ground station antennas currently have the TU Berlin? Are there currently joint projects with local German companies or startups? So I think it's more about the ground station infrastructure you're using.
Yeah, so communication is always very complicated. I would say it's like magic for us mechanical engineers, but it is at the same time it's very important. As we are usually seeing, communications is the bottleneck for satellites for getting the data. Another would be the power, but let's stay with communications, and it is a focus of us because we We are trying to build sensor networks. They have to communicate to each other, maybe, but maybe to the ground station, definitely to the ground station. So we are trying to increase this, the capabilities further and further, while we are trying to get the satellite smaller and smaller. So this is a critical point. And we, of course, have a ground station in Berlin, which is completely booked, since we're not only having one mission, we have several missions. So our whole, the rooftop of our faculty or institute, actually, the institute is crowded with antenna systems, and we try to use them. However, there is a lot of more spectrums in Berlin, of course. So there is a little bit problematic. We're always searching for more capabilities there, maybe going to more rural areas and building up a ground station there. And we are, of course, working in this communication, or in the communication subsystem with other companies together, because we are not building, or we are mostly not building the receivers or transceivers ourselves when it gets to higher frequencies. So this is actually something which companies would have to do, and if we can buy it, then we're happy to acquire it.
Cool. So just to ask it, or from my end, do you have antenna systems in the city?
Yeah,
on the roof. Yeah.
We have
okay.
an S-band antenna, so a parabolic antenna there, so more or less huge one. And there is I think it's 3 or 4 Yagi antennas. So it looks a little bit like an old skyscraper from the old times when you had this TV reception via antennas.
Yeah, absolutely. Okay. One last question from the audience, from Hisek. Sorry if I pronounce it wrong. Are there any interdisciplinary courses available at TU Berlin, like industrial design or architectural design for space? Interesting. Yeah.
So here's the disclaimer. I'm only 5 months now at TU Berlin, and I don't know all of the study programs there, but I would think so. I think industrial design and architectural design is, of course, there, but in how far they are very interdisciplinary for me, meaning that you can, for example, work with us. I'm not sure about this. However, if you maybe want to go into industrial design or into architecture, then come and ask us whether we can do something together anyways, because we're maybe interested in rockets, and then maybe there is something for an architect there as well to do.
Cool. Thank you. So my last question, because we have taken our 33 minutes already. So a
That's
question I'm asking.
I apologize.
No problem. No. I mean, it's an exciting discussion, and I'm really so happy to learn more about what's going on in Berlin. So the question I'm asking many of my guests at the end. So how can you envision our future as humanity in space? I know it's a very generic one, but I just want to see where your thinking goes. Are we a spacefaring nation, or are we?
That's definitely a very complicated one. So I would like to see that the mindset of the space station is somehow extended to the entirety of space. That means we have a peaceful cooperation there. We have, for example, data exchange, maybe hardware exchange, something like this. Hopefully we have satellite networks for Earth and atmospheric observations. So not only for, I'll speak very frankly, to acquire some money, but really do something with the data and have data available and use this data for sustainable developments on Earth. That would be interesting. And hopefully we're applying this one to space as well. So we have a sustainable space environment. We're doing refurbishing in space. We're doing debris removal. And hopefully we have a permanent station on the moon, and start exploring the universe, our universe, from there.
I'm happy that you said international station or on the moon. But you didn't, just said permanent. So I just added the international.
I think it implies that we're all working there together.
Yeah, I mean, at the moment it looks like, hey, he's a Chinese-Russian station or the American station. So, but we will see what future will tell us.
Yeah.
Thank you very much, Enrique. I'm afraid we have to come to an end. So even so, I would love to continue this inspiring talk with you, but I'm sure we will have another opportunity. Be assured we will continue with following Berlin or Europe in space for future Space Café web talks and in our magazine. Please, to our audience, stay tuned with us for a few more minutes. There are some interesting announcements you might be interested in. So before we go next week on a short break, do not miss in 2 days our next Space Café Germany in German language by Andreas Schepers and his guest, the German new space rock star Daniel Metzler of ESA Aerospace, and we are very happy to have him. Again, that's on Thursday, the 8th of July at 4 p.m. And then in, I think, 1.5 weeks, we have, during the summer break, a very special episode of our Space Law Breakfast with Stephen Freeland and his guests, Elina Morozova and Andrei Mishtal. And why during the summer break? Because they will talk about the legal implication of all these billionaires that are flying now to space, and potentially by that time we have seen that already. And then we will continue on the 3rd of August with some more great guests and some adapted concepts. So stay tuned. We listened to what you said. We had a poll with you over the last weeks. So, and we listened to you and we try to adapt it to a new concept, to make it more networking, to make it more engaging with you if you want. So all events are, except the 3rd of August one, are on Eventbrite as usual. And as always, we would like to hear your feedback. So please check in with us on Twitter, on Facebook or LinkedIn. Don't forget to sign up to our daily or bi-weekly newsletters. And if you like to treat yourself with something special, become a Space Watcher today. Your support will help us. Take your credit card, visit our fan shop at shop.SpaceWatch.Global. And yeah, I'm quite sure I said it before, but it is a truth. We need your support. Thank you all very much for your interest today. And thank you, Enrico, for your inspiring talk and being my guest. And thanks again to this wonderful and entire team behind the scenes for doing their great job day by day, week by week. Again, it was a fantastic cooperation with you over the, I think, over 100 space cafes that we run in the last 14 months. I hope you all will stay safe and stay healthy. Thanks for joining us. I hope to see you next week. Or no, not next week. I hope to see you in 2 days for the German-speaking community. In the meantime, visit our website or follow us on social media. And don't forget, become a Space Watcher. Thank you very much.